And I want to begin with a question that has been bothering me for years. Why do so many students believe they're bad at mathematics? Not that they struggle with mathematics, not that they find it frustrating, not that they would rather be doing something else. Why do they arrive at the conclusion that they are fundamentally incapable of mathematical thought? As a special education teacher, I encounter this every day. Students who can analyze social situations with remarkable sophistication, students who can navigate family systems, jobs, friendships, neighborhoods, multiple languages, and increasingly complex digital worlds. Students who can spot patterns in music, sport, fashion, gaming, and relationships. Students who are clearly, demonstrably capable of reasoning, and yet many of them sit down in front of a maths problem and immediately announce, I can't do maths. Not won't, can I do it? The conclusion arrives before the attempt. The more years I spend teaching, the less convinced I am that this is primarily a mathematics problem. I think it may be a story problem. Because when I look backwards through history, I didn't find generations of people walking around convinced they were incapable of mathematical thought. I find merchants calculating profit and loss in crowded markets. I find navigators crossing oceans with nothing but stars and memory. I find farmers tracking seasons, architects raising cathedrals, engineers building bridges, astronomers predicting eclipses, and stonemasons aligning monuments to the movements of the heavens. Most of these people never encountered mathematics as a school project. They encountered it as part of a story about getting home, a story about feeding a community, a story about building something that would outlive them, a story about understanding where they stood in relation to sky, sea, land, and one another. The mathematics was there, certainly, but it lived inside something larger. It lived inside purpose, inside necessity, inside meaning. And I can keep wondering whether we have forgotten this. So I think you know, I am currently writing a book called The Story of Math. And in many ways, it began with a simple observation from my own classroom. The students who struggle most with symbolic mathematics are often the same students who come alive when mathematics is embedded with narrative. Give them a story about a traveler, a builder, a trader, navigator, musician, and suddenly the mathematics becomes approachable. The symbols stop feeling arbitrary, and the problem acquires shape as an autistic Gestalt language processor, a Gestalt processor. This observation resonates with my own experience as well. I learned much of my mathematics from aging engineers, many of them war veterans, who taught through stories. And looking back, I suspect some of those stories served many purposes at once. They explained mathematics, they transmitted experience, they preserved memory. They may even have helped carry wounds that have never been fully spoken elsewhere. But what I remember most is that the mathematics never arrived alone. It arrived attached to something human. A bridge, a machine, a ship, a mistake. A lesson learned the hard way, a problem that needed solving. The mathematics rode in on the back of the story. And increasingly, I find myself wondering whether story may be one of the reasons mathematics was invented in the first place. Humans wanted to know where they were going, when the seasons would return, whether the harvest would arrive, whether the temple would stand, whether the ship would make it home. Mathematics emerged inside of those stories, which raises a troubling possibility. Perhaps what modern schooling often does is strip away the story and then wonder why so many students struggle to acquire the script. Perhaps the problem is not that children have stopped working or stopped loving mathematics. Perhaps the problem is that we've removed the stories and left only the symbols behind. And if that's true, then recovering the story is not enrichment, and it's not engagement. It's not a decorative extra that we add after the learning is complete. It may be one of the conditions that makes learning possible in the first place. So, if the argument I've made so far is even partially correct, then we need to ask a deeper question. When did mathematics become detached from story? And the answer, I think, is surprisingly recent, because if we travel backwards through history, mathematics rarely appears in an isolated subject. We don't find ancient people sitting around waiting for somebody to invent a worksheet. We do not find benchmark assessments, pacing guides, standardized tests, or disconnected procedural drills. What we find instead are communities trying to solve problems that matter. Mathematics emerged afterwards, not first, afterwards. The story comes first, the need comes first, the mathematics arrives in response. Now, consider a Babylonian merchant standing in a crowded market 4,000 years ago. They're not studying ratios because ratios appear on an exam. They're trying to determine the value of grain, livestock, cloth, labour, transport. Mathematics emerges from trade. It emerges from practical necessity of exchange. Or consider an Egyptian surveyor after the Nile floods. Property boundaries have disappeared beneath the water and must be established again. Geometry is not an abstract branch of knowledge, it's a response to a problem. Where does one's family's field end and another's begin? The mathematics emerges because the people need an answer, and the same pattern repeats. Polynesian navigators crossing thousands of miles of open ocean without modern instruments. Mayan astronomers tracking celestial cycles with astonishing precision. Arab scholars calculating inheritance, architecture, astronomy, and trade. Scottish stonemasons raising cathedrals, bridges, castles, and observatories from stone and timber. Different cultures, different technologies, different languages. Yet remarkably similar questions. How much grain do we have? How far must we travel? When will winter arrive? Will the structure stand? Will the ship make it home? How do we orient ourselves in relation to the world? When I look across these examples, what strikes me not is how different they are, it's how similar they are. Mathematics keeps appearing wherever human beings attempt to transform uncertainty into understanding. It appears wherever people seek pattern inside of complexity. And because of these problems mattered, the mathematics was carried inside the stories. The navigator's story, the builder's story, the merchants, the farmers, the astronomy story. Mathematics lived inside the narrative because the narrative explained why the mathematics existed in the first place. The problem came first, symbols came later. And nowhere is this clearer in the work of Muhammad bin Musa al-Khwarizmi. And I know I'm mispronouncing that terribly, I'm sorry. But many people know his work as a scholar who eventually gave the world algebra. Fewer realized that his mathematics looked very different from the mathematics most students encounter today. And when I first encountered his writing, something immediately felt familiar. Not because it was ancient or because it was linguistic. It was narrative, because it sounded like somebody trying to explain something. So today we might write x squared plus 10x equals 39. A compact arrangement of symbols that is completely opaque if you do not already understand the code. But he would have written something much closer to a square of 10 roots are equal to 39. Right? Read that aloud for a moment. A square of 10 roots are equal to 39. It sounds almost like the opening line of a puzzle, the beginning of a story, an invitation to a problem rather than a barrier guarding its entrance. The mathematics is still in there. Nothing has been simplified, nothing removed. The reasoning remains every bit as rigorous. What has changed is the form. The mathematics has been embedded inside the language, inside narrative, inside something that can be spoken, heard, remembered, and shared. For a long time, historians treated rhetorical algebra as a primitive stage on the road to symbolic mathematics, as though it represented an earlier and less sophisticated form of thought. I increasingly think that interpretation gets that exactly backwards. Rhetorical algebra is not primitive. It's accessible. It was designed for human beings. It was assumed that understanding should come before compression, meaning should come before notation. The language can serve as a bridge rather than a gate. And perhaps that's why it continues to resonate with me so strongly, both as an autistic person and as a teacher. Because what I see in al-Khwarizmi's work is not merely mathematics. I see somebody carefully constructing a story sturdy enough to carry the mathematics inside it. And once you begin looking for that pattern, you start seeing it everywhere. And once I began noticing how deeply story and mathematics intertwine throughout history, another question emerged. Why does story work so well in the first place? Why do human beings seem so naturally drawn towards narrative? Why do stories survive when facts are forgotten? Because if we're going to argue that mathematics once traveled through stories, we need to understand what stories actually do. And I think the answer is much deeper than entertainment. Story is one of the oldest information technologies our species has ever invented. Long before books, before schools, long before writing itself, human beings were using stories to carry knowledge across generations. How do you remember where the water is? How do you remember which plants are safe to eat? How do you remember the stars? How do you remember the history of your people? You wrap that information inside of story. And something remarkable happens. Information becomes easier to remember because facts are changed, because the facts have acquired structure. Stories create beginnings. Stories create endings. Anticipation, causality, coherence. One thing leads to another. The mind begins predicting what comes next. Meaning starts organizing itself. The story creates a shape that the memory can inhabit. And as I've spent the last several years writing about Gestalt language processing and Gestalt processing, I've found myself increasingly convinced that this matters far more than educators realize. Because for many GLPs, Gestalt processors, stories are not simply enjoyable, they're foundational, they're not enrichment, they're infrastructure. A common misunderstanding of language development is the assumption that language begins with individual words and gradually expands into larger structures. For many GLPs, myself included, the process appears to operate in the opposite direction. We acquire meaningful wholes first. We absorb patterns, phrases, exchanges, scenes, interactions, songs, stories, and conversations. The pieces emerge later. The whole of it arrives first. Analysis comes afterwards. Which means that when I think about language acquisition, I don't imagine a child collected isolated vocabulary words like beads dropped into a jar. I imagine a garden, a script garden. Every story plants seeds. Every conversation plants seeds. Every meaningful interaction plants seeds. Every favorite book, every television program, every bedtime story, every joke, every song, every moment of connection, all of them leave something behind. Not necessarily understanding in the conventional sense. Potential. Patterns waiting to be revisited. Patterns waiting to connect with other patterns. Patterns waiting to grow. Over time, these patterns become scripts. And I want to be very clear about what I mean about that word. A script is not merely something repeated. A script is stored experience, compressed experience. A package containing language, emotion, social information, rhythm, timing, context, and meaning all at once. The script carries far more than words. The words are simply the visible part. And what fascinates me is that stories appear uniquely well suited to producing these kinds of rich, interconnected scripts. A story contains characters, relationships, motivations, sequences, consequences, questions, resolutions. It creates a complete ecosystem of meaning. The story becomes a container large enough to hold many different forms of learning simultaneously, which brings me back to mathematics. Because I increasingly suspect that one reason mathematics was historically taught through stories is that stories provide exactly the kind of coherent wholes that human minds were designed to acquire. The Babylonian merchant was not memorizing a formula. They were participating in a story about trade. The navigator was not memorizing trigonometry. They were participating in a story about finding home. The stonemason was not memorizing geometry. They were participating in a story about building something that would stand for generation. Mathematics traveled inside the larger pattern, inside the larger meeting, inside the larger story. And when I look at modern classrooms, I sometimes find myself wondering what happened to the garden. Because increasingly we offer students fragments, a vocabulary list disconnected from narrative, a procedure disconnected from purpose, a symbol disconnected from story. And we're surprised that those fragments fail to take root. A seed scattered onto concrete is not evidence that the seed is defective. It may simply mean the conditions for growth are missing. The richer the script garden, the richer the language available for future growth. The richer the script garden, the richer the conceptual structures available for future learning. And perhaps this applies to mathematics as much as it applies to language. Perhaps before students need more practice, more intervention, more remediation, sometimes they may need something much older, a story worth carrying. So if stories are one of the primary ways human beings acquire meaning, then an uncomfortable question follows. What happens when the stories disappear? Because I didn't think the problem we're facing in modern education is simply that students know less. Nor do I think the problem is that teachers care less. Most teachers I know care very deeply. Many are working themselves to exhaustion, trying to hold together systems that no longer make sense. The problem, I think, is structural. Over time, we have reorganized education around a very different set of priorities. Knowledge becomes fragmented. Subjects become isolated. Procedures become detached from purpose. Assessment begins driving curriculum. Efficiency gradually replaces meaning. And because these changes happen incrementally over decades, they often feel normal to us. But if we step back and look at the larger pattern, something remarkable becomes visible. We have become increasingly skilled at delivering information whilst becoming increasingly disconnected from the conditions that make the information meaningful. The curriculum arrives in fragments. This week we learn this standard, next week we learn that standard, the week after we learn another. Each piece carefully aligned to assessment frameworks, pacing guides, benchmarks, accountability measures, and reporting requirements. Everything is measurable. Everything is trackable. Everything is defensible. And yet many students remain profoundly disconnected from what they're being asked to learn because they're refusing, because the coherence has been removed. The story has been removed. The larger pattern has been removed. I see this consistently in mathematics. Students are asked to find the sine of theta. Nobody tells them why human beings invented trigonometry. Nobody tells them about navigators crossing oceans. Nobody tells them about surveyors measuring land. Nobody tells them about astronomers tracking stars. The symbol arrives first. The story never arrives at all. Or students are asked to solve for X. They dutifully manipulate symbols across a page. And yet, nobody explains the problem that algebra was created to solve. Nobody explains inheritance calculations, trade disputes, architecture, engineering, astronomy, or the practical questions that gave rise to the mathematics in the first place. Again, the symbol arrives first. The story never arrives. And then we wonder why so many students experience mathematics as arbitrary, why they ask, when am I ever going to use this? I have increasingly become to believe that this question is often misunderstood. Teachers sometimes hear it as resistance. Curriculum designers sometimes hear it as laziness. But I think many students are asking a much deeper question. They're asking, what story does this belong to? Why does this exist? What human problem is hiding underneath the procedure? What am I actually learning here? And too often the system has no answer because the story has been stripped away. What remains is the shell, the notation, the procedure, the assessment item, the measurable outcome, the residue of learning after the meaning has been removed. And this matters especially for learners who depend heavily upon coherent wholes. As an autistic Gestalt processor, I often describe understanding as something that arrives through pattern before it arrives through analysis. I need to know what kind of thing I'm looking at before I can understand the pieces. Many of my students appear to operate in similar ways, yet Modern schooling increasingly presents the pieces first. The assumption is that meaning will emerge automatically once the fragments have accumulated. Sometimes it does. Often it does not, especially for students already positioned at the margins, students with disabilities, multilingual learners, students carrying educational trauma, students who have spent years receiving the message that their confusion is evidence of personal failure. The result is not merely academic difficulty, it's identity formation. A child who repeatedly encounters disconnected fragments begins drawing conclusions. I'm not good at maths. I'm not a maths person. I cannot do this. Eventually, the conclusion hardens, not because the student lacks ability, or because the conditions required for understanding were never fully present. The script was never acquired. The story that carried the script was missing. And so the script garden becomes sparse. Not empty, never empty. Oh. Human beings are always gathering stories from somewhere, but increasingly those stories arrive from outside the school rather than inside it. Games, films, music, online communities, social media fandoms. Students build rich conceptual worlds in all sorts of places. Then they enter classrooms where knowledge is presented as disconnected fragments, and we wonder why engagement becomes difficult. The tragedy is not that it does not have to be this way. The history of mathematics itself points towards another possibility, a way of teaching that begins not with the symbol, but with the story, not with the procedure, but with the problem, and not with the answer, but with the question that made the answer necessary. Because once story returns, something else returns with it. Curiosity. And curiosity changes everything. So, rather than continuing to talk about story in the abstract, I want to show you what I mean. Let's imagine that I'm teaching trigonometry, not the way it usually appears in a textbook, not a list of definitions to memorize, not as a collection of procedures attached to a future assessment, but as story, a human story, a kind of story from which mathematics emerged in the first place. Now imagine, if you will, standing on a rocky coastline thousands of years ago. The sea stretches beyond the horizon. There is no GPS, no sat-nav, no satellite imagery, no radar, no map app waiting in your pocket. There is only the sky, the ocean, your memory, and the knowledge passed down by those who sailed before you. Out on the water, you see another vessel, and you want to know how far away it is. The problem is obvious. You cannot walk to the ship. You cannot stretch a tape measure across the ocean, and you cannot measure distance directly. And suddenly, the audience has a reason to care. Not because I've introduced a mathematical standard, because there is a problem, a real problem, a human problem. The kind of problem that creates mathematics. So what do people do when they cannot measure something directly? They measure something related. They observe an angle. They establish a baseline. They create a triangle. And the triangle, quietly and elegantly, reveals information that seemed inaccessible only moments before. This is where sine, cosine, and tangent enter the story, not as vocabulary words or definitions, as characters, as tools, as solutions. Each one describes a different relationship hidden inside the triangle. Each one offers a different way of extracting knowledge from the world. The student is no longer memorizing Soka Toa. A student is participating in an ancient human project. How do we know things that cannot be measured directly? How do we see beyond immediate reach? How do we transform observation into understanding? Now the mathematics has purpose. Now the ratios have meaning. Now the script has somewhere to live. And then perhaps a few weeks later, we arrive at the sequel. The student already knows the characters, sine, cosine, tangent, old friends. The question is no longer what they are. The question is what human beings did with them. And suddenly the story expands. We leave the shoreline and we follow the navigators in the open ocean. We watch sailors determine their position using stars. We watch traders connect distant ports. We watch explorers map coastlines. We watch astronomers measure the heavens. We watch architects raise cathedrals whose towers seem impossible. We watch engineers build bridges, and we watch observatories aligned to solstices and equinoxes. We watch generations of human beings using the same mathematical relationships to orient themselves within a world far larger than any individual life. And something important happens here. The mathematics stops feeling like mathematics, or perhaps more accurately, it starts feeling like mathematics again, not the school subject, not a collection of procedures, a way of orienting ourselves, a way of finding our place, a way of transforming uncertainty into understanding. The navigator wants to know where they are. The architect wants to know whether the structure will stand. The astronomer wants to know where the stars will appear. The community wants to know when the seasons will return. Different stories, same mathematics. The same underlying human desire to understand our relationship with the world around us. And this, I think, is what happens when story returns. The mathematics does not become easier, does not become less rigorous. The mathematics becomes visible. Students can finally see the human questions hiding underneath the symbols. They can see why somebody cared enough to invent these ideas. They can see why these ideas survived. And they can see themselves inside the story. And once that happens, the trigonometry is no longer floating alone on the page. It belongs somewhere. It belongs to the navigator standing on the shoreline. It belongs to the builder raising a cathedral. It belongs to an astronomer watching the sky. It belongs to a human conversation about orientation, distance, pattern, and place. And that perhaps is what education should be doing more often. Not merely teaching students the answers, helping them discover the questions that made those answers necessary. So as I was preparing this, I kept finding myself returning to a diagram that I encountered recently. It describes a relationship between inevitability and irreversibility. No destiny and no prediction, something subtler. The idea is that many processes begin as a kind of directional pressure, a tendency, a coherence, a gathering pattern. Then comes passage. Then comes history. What was once possibility becomes reality. What was once potential becomes structure. What was once future becomes past. And the more I sat with the idea, the more I realized that it may describe not only time, it may describe mathematics and perhaps learning itself. Because if we step back far enough, mathematics has always been concerned with transformation. A merchant transforms uncertainty about trade into understanding. A navigator transforms observations of stars into knowledge of location. An architect transforms geometry into a building. An astronomer transforms patterns in the sky to predictions about the future. Again and again, mathematics appears wherever human beings seek to convert uncertainty into understanding, possibility into knowledge, potential into structure. The language changes, the symbols changes, the cultures change. The underlying movement remains remarkably consistent. Something hidden becomes visible. Something uncertain becomes knowable. Something possible becomes real. And learning follows a very similar path. One of the assumptions built into much of modern education is that understanding arrives at the moment of instruction. The teacher explains, the student understands, the assessment verifies, transaction complete. Well, that was never matched my experience either as a learner or as a teacher. Most of the important things I've learned did not arrive fully formed. First, there was curiosity, then confusion, then a period of time where nothing seemed to be happening. Then, sometimes weeks or months later, the pattern would suddenly become visible. The understanding emerged afterwards. The lesson was not the understanding, the lesson was the passage. And this is where I think the story becomes so important. The story creates the pull. The story creates coherence. The story creates the sense that something matters before we fully understand why. A good story generates questions before it provides answers. A navigator standing on a shoreline, a merchant calculating grain, a stonemason raising a cathedral, an astronomer watching the stars. Story creates tension, creates curiosity, creates the desire to know. The mathematics becomes the means by which the tension is resolved. The lesson becomes the passage. Understanding becomes the residue. What remains afterwards, the altered structure, the changed landscape, the new pattern that the learner can now perceive. There's one reason I increasingly resist the idea that education is primarily about information transfer. Information can be transferred instantly. Meaning cannot. Meaning requires passage. Meaning requires time. Meaning requires a learner moving through uncertainty towards coherence. And perhaps this is the deeper reason why story matters. Not because stories make mathematics entertaining, because stories improve engagement, or because stories help us remember facts. Stories create the conditions under which meaning can emerge. They create the pull that draws us towards understanding, which brings us back to mathematics itself at its heart. Mathematics may not simply be the study of numbers. It may be the study of relationships, the study of patterns, the study of transformation, the study of how one state becomes another, how possibility becomes reality, how uncertainty becomes understanding, how inevitability becomes irreversibility. And if that's true, perhaps the mathematics is not merely something we teach. It's one of the fundamental ways human beings learn to orient themselves within a changing world. A way of making passage visible, a way of seeing transformation as it happens, a way of turning mystery into meaning. So I want to return to the question from which I began. Why do so many students believe they're bad at mathematics? After everything we've explored today, I find myself less convinced than ever that this is primarily a problem of ability. When I look at human history, I don't see a species incapable of mathematical thought. I see merchants calculating trade routes. I see navigators crossing oceans, farmers tracking seasons, architects raising cathedrals, astronomers mapping the heavens. I see communities across thousands of years and countless cultures using mathematics to solve problems, make decisions, tell stories, and orient themselves within the world. Mathematics was never reserved for a gifted few. It was woven into ordinary life. It emerged whenever human beings encountered uncertainty and sought understanding. And perhaps that's why it's because mathematics emerged inside stories. Human beings wanted to know where they were going, when the rains would come, when the seasons would arrive, when the harvest would come, whether the bridge would stand, whether the ship would make it home. And the mathematics grew inside those questions, inside those needs, and inside those stories. Which leaves me wondering whether many of our students are not struggling because the mathematics is beyond them. Perhaps they're struggling because we've handed them the answers whilst holding the questions. We've given them the symbols before the stories, procedures before purpose, abstractions before meaning, and then we've mistaken their confusion for inability. As a teacher, and as an autistic Gestalt processor, I increasingly think about learning as the cultivation of a garden. Every story plants something. Every conversation plants something. Every moment of wonder plants something. Over time, those seeds become the script moving through which future generations and understanding grows. The richer the garden, the richer the possibilities. The richer the garden, the richer the language available for making sense of the world. And when I look at many classrooms today, I don't see children who have lost their capacity for learning. I see children whose script gardens have been asked to grow without enough seeds. Not because anyone intended harm, but because somewhere along the way we become so focused on delivering information that we forgot to cultivate meaning. We've removed the stories and left behind the symbols. And perhaps that's why so many students never get the chance to discover that they were mathematicians all along. Not because they can solve every equation or memorize every formula, but because they're already doing what human beings have already done. They're looking for patterns. They're seeking relationships, trying to understand where they are, where they're going, trying to make meaning from an uncertain world. The good news is that this is not a problem that requires us to reinvent mathematics. The mathematics is already there. The curiosity is already there. The capacity is already there. Perhaps the work before us is something both simpler and more difficult to remember, to recover. To recover the questions before we teach the answers, to restore meaning before we demand mastery, to plant stories before we expect understanding, to return mathematics to the human story from which it came. And in doing so, perhaps we help more students discover that they belong there too. Thank you.